All right, I guess we can go ahead and get started. Well, hello, good morning to our colleagues in China and Asia, and good evening to folks in the US, and hello to everyone else. I'm Ali Hassan Begi from Global Efficiency Intelligence. We are a consulting firm based in the US doing work on industrial decarbonization and fair amount of work on industrial electrification. We are organizing this webinar in collaboration with Lawrence Berkeley National Lab, who also collaborated in writing the report that we just published. We are having a presentation today. We are going to introduce the team members and also have some technical presentation. And then that will be followed by Q&A. Since this is a webinar, please, if you have any questions and comments, type it in the chat box. And during the Q&A session, we will read the questions and try our best to respond. Let me share my screen. Can you see my screen? Cecilia, others? Okay. Perfect. So if you are here for electrifying industrial heating in China, you are at the right place. As I mentioned, this was a collaborative project with Lawrence Berkeley National Lab. The team members are listed here: Gibran Zuberi, Hongyu Lu, Nan Zhou, and myself and Cecilia Springer from Global Efficiency Intelligence. We have been working together for many years. Even before Global Efficiency Intelligence, I was working at Lawrence Berkeley Lab, so it's a team that has worked together for many years. We are gonna give a very brief introduction, then we will have technical presentation and then the Q&A. And also I want to thank Climate Imperative Foundation for supporting this study. The report was just published. Some of you might have seen it on LinkedIn or got an email from me. So if you're interested, you can go to our website and download the report. It's available for free. We also are in the process of finalizing the translation of at least executive summary of the report into Chinese language, and we will publish that soon also on our website. So here's the team member. It's myself from Global Efficiency Intelligence, and we have Cecilia Springer also from principal at Global Efficiency Intelligence, Nan Zhou and Hongyu Lu from Lawrence Berkeley National Lab, who will be speaking today. We also have Gibran Zuber, who is the co-author, but is not presenting today. So perhaps we can have a very brief introduction from the team member. Just you can tell your name and your work. Cecilia, would you like to start?
Sure. Hi, everybody. I'm Cecilia Springer from Global Efficiency Intelligence, where I work on a wide range of industrial decarbonization issues, and especially electrification of industrial heating.
Thank you. Hongyu?
Sure. Thanks, Ali. My name is Hongyu Lu from Lawrence Berkeley National Laboratory, working with Nan and Ali and Cecilia. My focus has been on industry, specifically on the heavy industries, such as cement and steel, also working on cross-sector topics such as electrification. Really glad to be here.
Thank you, Hongyu. And Nan, you can introduce yourself, but also would like to give you a few minutes remarks on the importance of this topic in China. And you have done a lot of work on industrial decarbonization in China. Just put this topic into context in China.
Okay, thank you, Ali. Good evening, good morning, afternoon, and my name is Nan Zhou, a senior scientist at Lawrence Berkeley National Laboratory, and I've been working in the lab for 20 years, worked with Ali and Hongyu and Cecilia in the past, and my expertise covers a wide range of topics, but also I worked for a while on the industrial energy efficiency, working with Ali and in cement steel plants in China. The other area of my focus is more on the energy demand modeling and the policy analysis. So So with that, I will just give a very quick kind of background introduction and what led to this project we're doing together with Ali and Cecilia. So as you probably all know, and there's a really pressing need to address the greenhouse gas emission from industry sector, particularly in the heat part, industry heat, and accounts for a large portion of that emission. And in China, it's much more significant. So like for the industry energy and consumption, 70% of that and is attributed to fossil fuels for process heating and other thermal process, and with coal and other natural gas and all these fossil fuels. And it's also even in the overall energy consumption mix, and is a large portion. So there's really pressing need to decarbonize, but it's also a very challenging sector, as many of you know. And so we started this project by exploring technology pathways and policy options, and that can help us tackle this challenging topic. And so we focus more on the cross-cutting and heat applications across the different sectors in industry, exploring potential for low, no carbon renewable thermal technologies, and including electrification, renewable natural gas, biogas, sustainable biomass and solar thermal, and then other types of the technologies. And we also explore the policy actions and looking at the measures and that could help us overcome barriers for the deployment of these alternative technologies or sources, and so they can be scaled up and quickly. And also identify research development and demonstration needs and gaps, fostering this public-private partnerships down the road. And our methodologies involve a combination of qualitative and quantitative analysis, and including desktop research, literature review, survey, and interview. And also we reviewed existing policies and talked with stakeholders and have their advice and consultancy. And they engaged some of our stakeholders, and we had a webinar, and halfway through the project received very valuable comments, insights. So I really and want to thank all of you for these suggestions and to help shape the project. And now we have this research wrapped up. And I'm very excited to share with you the final findings from the research project, and also share with you our policy suggestions, and really welcome you for any questions and discussions and follow-up and down the road. So with that, I will hand it over to our colleagues to and present our research findings.
Thank you very much, Nan, for setting the stage, giving the background about this project. So we can get started with our presentation. First, Hongyu Lu will give some information about the energy use in China, industrial sector, and emissions, just to show why this is so important. Hongyu?
Thank you. Yeah, just want to give a quick background on why we are looking at China's industrial sector. The chart showing on the left shows China's primary energy consumption by different sectors, different end-use sectors. And the gray part shows that's how much China's industrial sector consumed in terms of the total primary energy use in China, about 65%, the largest end-use sector. And that's accounting purchase electricity, the fuels used for electricity generation as well. The chart showing on your right shows the carbon dioxide emissions breakdown at the end use sector level. Again, that tells a similar story where the industry sector accounted for about 70% of the energy-related CO2 emissions in China. This just speaks the story that why we're working on the industry sector and why it is critical to decarbonize China's industrial sector in order for China to achieve their climate goals, which is to reach carbon peaking before 2030 and carbon neutral before 2060. Next slide, please. Looking at what kinds of fuels that China's industrial sector are currently using, chart on the left, it shows that at the manufacturing sector, if we're looking at just the manufacturing sector, we see at the final energy use level that China's manufacturing sector actually uses a lot of coal. So the bottom one showing the dark one, that's a direct coal user using coal to provide heat, to provide as a feedstock, to provide the energy that's needed in these sectors. And the next one is coke, which is another form of coal that's used directly within China's industry sector. And that just accounts for about 50% of China's final energy use within the manufacturing sector. And if we compare China's industrial energy use by source with other countries, which showing here on the right, we see China's choices for energy use in the industry sector is very much dependent on coal as compared to other countries such as Germany or United States, which are more dependent on natural gas or has a higher share of electricity as well. And that speaks the challenge, but also speaks to the opportunity of where we can leverage the decarbonization of the power sector and also achieve significant mitigation in the industrial sector. With that, I'm going to hand the slides and the presentation back to Ali for today's conversation.
Thank you, Hongyu. This is important to highlight, lots of coal, fossil fuel, we want to transition away from it, shift to electricity, but of course, renewable electricity. That's the whole point here. So before jumping into electrification, I wanted to step back and show the bigger picture. When we talk about industrial decarbonization, almost everything you do falls under one of these 5 pillars of decarbonization. We have used this as a framework in different studies in the US and other countries. So, and probably many of you are familiar with. So these 5 pillars are what material efficiency, circular economy, anything that, talks about circular economy, reuse, recycling, byproduct synergy falls under there. Energy efficiency, we all know very well about it. Third is electrification of industrial heating, the topic of today's conversation. Fourth is what we call low carbon fuel feedstock energy sources, lower carbon fuels. For example, green hydrogen falls there, sustainable biomass falls there, low carbon feedstock, biofeedstock falls there, or low carbon also feedstock in terms of green hydrogen for iron making, DRI iron making, and things like that. And then last one is CCUS, carbon capture, utilization, and storage. So what we want to highlight here, today we talk about electrification, but we should not lose sight of all these other pillars that all need to go in parallel, hand in hand. In certain sectors, some of the pillars, they play a more important role, and in some other sector, some other pillar, but all these pillars need to be followed if we want to get to net zero industry. But today we talk about electrification pillar for the industrial heating. Also, just to let you know, probably many of you are aware, we have done fair amount of work on this topic. These are some of the reports we have published in recent years on electrification of heating in industry, mostly in the US, and we are trying to bring that expertise and experience and do the similar detailed subsector level, system level analysis in other countries, this one for China that we are presenting today. For China, we did a study and we published last year for the textile industry. We did a study on electrification of heating in textile industry in China, Japan, and Taiwan. That is why textile industry was not included in this report that we published today, because it was extensively and in detail studied and presented in the other report. So if you are here, you are interested in textile industry in China or overall, please look at the other report. So when we talk about electrification industry, some people immediately jump into hard to electrify sectors. For example, cement industry. This is a sector we don't have a commercial technology to electrify, and it's more challenging, although people are working on that technology as well. But there are many other sectors, and heat is used differently in different sectors in terms of the service it provides, the temperature profile, etc. This graph shows the temperature profile of heating in different sectors. You can see it's significantly different. In some sector, substantial part of heat is for low and medium temperature heating. For example, look at food sector. Almost all the heat is for temperature lower than 150 degrees C. Same is for textile. All of it almost is below 200 degrees C. And even in some of the heavy industrial chemical industry, significant portion is for low and medium temperature. And based on some study in the US, 2/3 of process heat in the US was for applications below 300 degrees C. So that's important because relatively speaking, when it's lower temperature heating with the existing technology, technically speaking, is easier to electrify. Nevertheless, we do have some industries like a steel industry or aluminum industry that we do have high temperature, and we do have electrified technology. For steel is electric arc furnace, or even hydrogen DRI, you can call that indirect electrification, and aluminum, primary aluminum making is electrolysis anyway. So that's something to keep in mind. The nature of electrification is different in different sectors. When we talk about electrification, we have looked at it from two different angles. One way to electrify is you go to your boiler room, you don't touch your process, and you basically electrify your boiler. And it's a commercial technology, has been around for decades, and we have analyzed it in detail for all the subsector, and my colleague Cecilia is going to talk about it in a few minutes. The other way is you go to your processes, you have dryers, heaters, kiln, furnaces, and you electrify those processes given certain current processes that can be heated using electricity. For example, you have a dryer using a steam or hot oil or even direct fire system for heating or drying. You can buy a machine that does the same thing, but it uses electric coils and electricity for doing that. And many sectors, actually, those machines are available. You can buy them today. For some of them are emerging. So that's what we call electrification of end-use industrial processes. And we have done extensive analysis there also for this category. Don't try to read this, but basically this is to show that for this electrification of end-use processes, it varies from sector to sector. So we looked at a variety of sectors from food and textile all the way to a steel industry, chemical industry. There are all these major processes that require heating, and you can actually go and electrify those using different machines or processes that are electrified heating. And we have looked into these subsector and one level deeper into the systems, and we have basically done the analysis how to electrify those. When we talk about electrification, there's a wide range of technologies, many of which commercially available today that can help us to electrify heating in industry. Some of them you have heard, like electric boilers, heat pumps, industrial heat pumps, electric arc furnaces, induction heating, RF heating, microwave heating, etc. Each of these types of heating, they have their own characteristics. They're suitable for certain types of heating for certain processes. So we are not limited to just one technology. And that is a strength, because in industry, it's very complex. We have different processes, different subsectors. So we need a range of technologies that can provide that sweet spot for the heating for that particular process, if we want to electrify that end-use processes, not just the boiler. So what we did for 14 subsectors that are listed here, from aluminum, glass, all the way to quite a few subsectors of food industry, beer, beet sugar, milk, etc., and then a steel industry, a steel production, entire steel production, but also a steel reheating process and paper industry, and a few more. We looked into this subsector. We identified some of the main processes in these sectors, and we analyzed how the heat is used, the temperature profile, the nature of the heating service, and then we identified suitable electrification technology for that process, or several main processes. And based on that, we did the analysis, we did the kind of assessment of the integration of these electrified processes into the system. And then from there, we did the calculation for the energy saving, CO2, and cost. So that was our basically analysis process. For the CO2 emissions assessment, we developed two scenarios, primarily based on the electricity emissions factor, because we did projections up to 2050. So it's important to basically see where the electricity emission factor is going. China, as you all know, currently has a very high emissions factor for electricity generation. And that's one of the reasons people say, oh, we should not electrify. And that is actually not true. So for the baseline scenario, we assume that the electricity emission factor, basically electricity emissions will go to zero in 2060. And that is in line with China's national target of carbon neutrality by 2060. So that's, to be honest, is a conservative scenario. And then we have an ambitious scenario where we said, okay, the grid will decarbonize, but then corporates, they will start procuring renewable electricity through PPA and other things in China. They have it, by the way. China has a infrastructure in place in terms of the market. And then they start adding, in addition to getting from the grid that is slowly decarbonizing, also they're adding their own, cleaner electricity to the mix. We assume around 1/3 comes corporates buy from renewable through PPA in 2030, around half in 2040, and then by 2050 through the mix of grid and corporate PPA, they individual company can get to zero carbon electricity in 2050. So that's a more ambitious scenario, just to show how this will impact, the results of electrification in terms of CO2 emissions. The numbers are presented there in the table. So we have done this analysis, as I said, for 14 sectors, but don't have time to talk about all those. Actually, I'm realizing time is going really fast. So just one example for the secondary aluminum production. So to produce secondary aluminum, usually there are furnaces that use fossil fuel. Other parts of the world, they use natural gas. In China also, they use coal to basically do the heating and melting of the aluminum scrap to produce aluminum. You can use induction furnaces, different types of induction furnaces. In this case, we use single shot induction furnace to basically do the same thing. There are pros and cons to both approaches. Some of the challenges with induction furnaces in terms of the size, more important, the electricity price, etc., are there. But the sizes are increasing, and technically speaking, there is no challenge really to go that direction. So it's a commercial technology to implement even today. Not to say that it will be cost effective, it will show the cost result, but it's technologically possible. So if you do that, you can see from the table, in terms of energy intensity, kilowatt hour per ton of aluminum produced, the electrified process in final energy term will cut your energy by more than half. So that's significant reduction in energy intensity, because electricity, as you know, is higher grade energy. So it can really improve efficiency. And then from there, we went to the national level, multiplied by production and some projections, and quantified what would be the overall change in energy use if we electrify secondary aluminum making in China. By the way, China is the largest aluminum producer in the world. And you can see we are talking about tens of petajoule per year. The aluminum production increase, that's why you can see a significant increase in saving. It's a change in energy use, that's why you see the negative value implies reduction. One thing to note here, these values we showed today are total technical potential. So if all this industry is electrified, what would be the savings? So to show you 100% adoption rate and the total technical potential. In reality, we all know it will be a more gradual implementation of these technologies. Let's talk about CO2. CO2 is interesting actually case depending on the industry. The graph on the left-hand side shows the change in CO2 emission from electrifying secondary aluminum making in in China. Also 100% adoption rate. The results are for 2030 up to 2050, and for two scenarios: base scenario that assumes grid go to zero in 2060, an ambitious scenario that assumes corporates start buying some PPA renewable and having clean electricity. You can see even under baseline scenario, which is more conservative, we are in 2030, as soon as 2030, we are getting reduction in CO2 emission by electrifying. So despite the common belief that, because China grid is dirty now, will be dirty in 2030. In many sectors, our analysis show, you see in the report that in 2030, in many sectors, we get emission reduction from electrification based on the trajectory of the grid emission factor I showed you. And of course, if you go with ambitious scenario, you start putting more renewable through PPA, you definitely will get your emission reduction. And even better than that, even today, any aluminum production or any plant in China can go electrify and just buy enough renewable electricity through PPA and get emission reduction, even today. Keep in mind, you do not need to have zero carbon electricity for electrification to make sense or be carbon beneficial. You just need to have enough clean electricity in your mix to be below certain threshold, depending on the technology you implement. And there you go, you will get your CO2 emission reduction. Another thing, in some sector, we did the analysis initially under baseline scenario, because grid is not clean enough, you might get emission increase, and then 2040 and beyond, you get decrease. So we looked at what we call cumulative change in CO2 emission over what we call lifetime, but basically 2030 to 2050. So even in those cases where emission increase initially, if you look at the 20 years, you will still get a significant net reduction. So from the planning policy perspective, or even corporate planning perspective, you might even go with cases where in the beginning, for a few years, you might increase your emission. But if you go through the plan and in terms of adding enough clean electricity, then you will be good to go to electrify and get the benefits over the lifetime of the technology. On cost, we did the energy cost analysis for all this electrification. So this graph shows conventional process versus electrified process energy cost per unit of production, per ton of aluminum produced in 2030 and 2050. Dark blue is carbon cost, light blue is fuel cost, and green is electricity cost. So it's very clear in 2030, if you electrify, the cost, energy cost is going to be probably more than twice in electrified process compared to conventional. That is basically the #1 barrier to electrification in many places, in many sectors, especially in places like US, where we have cheap natural gas, which is a relatively cleaner fossil fuel. It's really not helping. In China, it's coal, of course, mostly. But if you go into the future, if there is sufficient carbon price, and given that price of renewable might still drop, or it's not increasing as fast as the price of certain fossil fuel, then based on our projection, at least of energy price, electrified prices can get cost competitive in the future. So that's something to keep in mind. One thing I want to highlight, when you go to industrial plant, there's all this input to make the production, whether it's aluminum and all. In certain sectors, energy cost is larger share of production cost, but in certain sectors, really is small, especially when you talk about lighter industry like food, aluminum, food, textile, etc. There's labor cost, material cost, and energy cost often is less than 10% of the total production cost. So even significant increase in energy costs will have minimal effect on total production cost, final production cost. So that's something to keep in mind when we are planning about, corporate deep decarbonization and what would be the impact on the cost. Just by doing electrification in these 14 sectors, as you know, industry has many other subsectors. We are talking about gigaton scale annual CO2 emission reduction. If we can manage to use, of course, complete 100% renewable electricity. And that's only the case under the ambitious scenario in 2050. That's why I've highlighted. 2050 ambitious scenario assumes zero carbon electricity. So if you want to see what happens if we electrify and use renewable, that's what happened. And if you sum them up, it's a gigaton scale per year. And of course, if you add all these other sectors, we are talking about significant CO2 reduction potential. So that was a very quick example of this subsector level end use process electrification. And now my colleague Cecilia is gonna tell you more about, okay, if you go to boiler room and electrify boiler in different sector, what are the results for that in China? Cecilia?
Thanks, Ali. Yeah, I'll be talking about our findings. Hi, I'll be talking about our findings on transitioning to electric boilers, which we also analyzed in terms of the potential energy savings, emissions impacts, and cost implications. So we know that one of the benefits of switching to electric steam boilers is that they have a higher efficiency of 98 to 99% compared to about 70 to 80% for the typical combustion steam boiler, depending on various variables such as their size, fuel type, and condition, and so on. We also know that steam boilers, electric steam boilers, have been commercialized and widely used for decades. However, even though they are more efficient and they're a mature technology, they still hold quite a small market share. The electric boilers that we're studying function either as electric resistance boilers, where an electrically heated element transfers heat to water, or as electrode boilers, where an electric current directly heats the water. And electric boilers offer various other advantages besides efficiency, like reduced air pollution, quicker ramp-up times, and so on. Next slide, please. And just to characterize the sort of feasibility of the electric boiler technology in China at the moment, they do have a large emissions reduction potential, especially if paired with renewable electricity. It's a mature technology, as I mentioned. They're available domestically in China as well as around the world. The supply chain is also mature, and then there is also a high readiness of local human capacity. Next page, please. So in our analysis, we looked at energy savings from switching from combustion boilers to electric boilers. So on the left, this graph compares the current energy demand in combustion boilers, and then the potential electricity use if boilers are electrified in Chinese industry in the base year of our analysis, or 2022, showing that electric boilers can reduce the boiler on-site energy demand by 28% across the sectors studied. And on the right, we have a breakdown by sector of energy savings. And the top graph is the 4 most energy intensive industrial subsectors in China, while the bottom graph shows the remaining subsectors that we analyzed. And so just to note, these are a slightly different group of subsectors than for the prior in-use electrification analysis based on data availability. Next slide, please. So talking about emissions, I think as Ali mentioned earlier, because of the carbon intensity of China's grid, that in certain sectors, that there may be a sort of near-term increase in CO2 emissions from electrification. And this could be around 28 million tons of CO2 from the base year to 2030 in our baseline scenario. However, in our ambitious scenario, which projects increased procurement of renewable electricity and a faster achievement of net zero electricity, then the annual change in emissions is negative in 2030, with further reductions in emissions over the study time period. So, you know, comparing across scenarios, boiler electrification is projected to result in 237 to 372 million tons of CO2 emissions reductions per year by 2050 between the 2 scenarios. So just to underscore what Ali mentioned earlier, that doesn't mean don't electrify in the near term, because plant level emissions reductions can be achieved today when electrification projects are tied with sufficient renewable energy supply. Next slide, please. So we also break down emissions by subsector and the potential change over time. So the top row of graphs shows the 4 most energy intensive subsectors in China. The bottom row shows the remaining that we analyzed. And on the left, we have results from our baseline scenario, and on the right for our ambitious scenario with more rapid grid decarbonization and renewable energy supply. And so you can see that, for some sectors, there is a near-term increase, but that especially for the most energy intensive subsectors, the annual emissions reductions could reach, for example, 167 million tons of CO2 in chemicals, 133 million tons of CO2 in steel under the ambitious scenario. Next slide, please. So we also looked at costs, and here this graph is comparing 2030, 2050 for combustion boilers and electrified boilers. We can see that in 2030, the energy cost per ton of steam production for the electrified boiler process is quite a bit higher, almost 3 times higher than for combustion boilers. However, especially taking into account China's emissions trading system, which will be scaled up to cover various industrial sectors in the next few years, then by 2050, the energy cost per unit per ton of steam production is only about 15% higher for the electrified process under our ambitious scenario. And so, of course, the availability of lower cost electricity would reduce this cost differential. And so we've shown in error bars, what it would look like with a 50% lower electricity price, for example. And this would easily bring the electrified process in line with the conventional process per ton of steam by 2050, especially if projected fuel costs also increase. Next slide, please. So we also look at these costs and break them down by the different sectors that we analyzed. And it's clear that for some sectors, the electrification process will be relatively less costly in terms of cost per ton of steam by 2050. So this graph is showing what the cost comparison would be in 2050, especially when taking into account carbon costs. And so again, lower electricity price would change this ratio, higher fuel costs, and so on. And some of the sectors with more favorable break-even points, so to speak, would be machinery, transport equipment, and here for boilers, we did look at the textile sector. However, we didn't consider capital or operation and maintenance costs for boilers, but it's important to note that in general, electric boilers are less expensive than conventional fuel-fired boilers in those respects. So next slide, please. So we also wanted to talk about the impact on the electricity grid of industrial electrification. Of course, this is critical in terms of the increased demand that electrification might put on the grid, as well as determining its overall impact on decarbonization based on the carbon intensity of the grid. So next slide, please. China's current electricity generation mix is very coal intensive, with nearly 2/3 shown in the graph on the right, coming from thermal sources, mainly coal. And there is a significant amount of low carbon energy, including 12% from wind and solar and about 16% from hydropower. But it's really important to note that China's grid is rapidly decarbonizing. So in terms of wind and solar, China continues to install more renewable energy capacity each year than any other country, with 43% of global renewable energy capacity that was added in 2021 around the world happened in China alone. China also released a 14th five-year plan for renewable energy last year, setting a target to reach 18% non-hydro renewable electricity generation by 2025, and to reach 1,200 gigawatts of installed wind and solar capacity by 2030, but it's already on track to meet this target 5 years ahead of schedule. So the graph on the left shows cumulative installed capacity for solar and wind over time. And as of the end of 22, China had reached nearly 400 gigawatts of operating solar installed capacity, growing at 22% per year, and 365 gigawatts of wind installed capacity, growing at 9% per year. So as China's grid decarbonizes, this will obviously increase the emissions benefits of electrification. Next slide, please. We also summed up the additional load that would be needed to meet the needs of the electrification processes studied in our report. And so, while electrification results in a reduction in total annual final energy use across the sectors we studied, it does, due to higher efficiency, it does lead to a higher demand for electricity. And so this figure shows that electrifying the industries that we studied results in an increase in annual electricity load. It was quite low in most sectors, but paper and iron and steel do have a significant additional load. So to fully electrify all of these industries, an additional 620 gigawatts of power generation capacity would be needed by 2050. And for comparison, China will be adding dozens of gigawatts of renewable energy capacity per year over the next few years, eventually aiming to add over 100 gigawatts of renewable energy capacity per year to reach that target. So it's important to note that demand is growing, but so is supply. And I will turn it back to Ali to talk about some of our study conclusions.
Thank you, Cecilia. I think this graphs on electricity and the remark Cecilia just gave, because when we talk about electrification in China, everybody says, oh, the grid is dirty. Yes, it is, but it's decarbonizing rapidly. The scale of demand will be high, but the scale of supply is also significant. Like in 1,200 gigawatt of renewable is equal to the entire power generation in the US. And that's only renewable in China. And they're achieving that by 2025, I think. The target was 2030. So significant clean electricity supply is coming. So we need to start electrifying slowly. Of course, the numbers we are showing you is 100% adoption rate. In reality, the adoption rate will be gradual. So we ask you a question, all of you who are here, you answered this. What are the top 3 challenges to electrify industrial heating in China? And the word cloud shows basically the result of 140 plus people who registered and replied. So it looks like capital cost is the big one. Technology maturity, availability, renewable electricity supply, grid capacity, stability. These are some of the top one that is standing up, which is very interesting, and it's all true. Although on the cost side, especially for boiler, as Cecilia said, usually electric boilers are actually cheaper than conventional boiler. Another thing to keep in mind, 95% of boilers' lifetime cost is energy cost. So if you're a corporate, want to decarbonize your supply chain in China, or making policy, sometimes you should not look into capital cost. You should look at operational and energy cost and try to come up with innovative financing scheme that help with the operational cost, which is mainly energy cost, because electricity is significantly more expensive than coal or natural gas in many places in the world, including in China. And that has become the #1 barrier. We are dealing with that as we speak. We are working with some corporates. They're trying to decarbonize their supply chain in Asia, primarily textile industry. And it's not really the capital cost problem, it's the energy cost problem. So that's something to keep in mind. So yeah, we went definitely over time in terms of the time we wanted to spend, but I think it's clear, significant potential to decarbonize Chinese industry if we electrify and of course tie it with renewable electricity. That's a given. Like, we don't want to electrify and use the current grid, of course. I mean, you can start using the current grid, but you need to start adding renewable electricity to the mix. Even in many sectors by 2030, even we can get significant emission reduction, even under baseline scenario that we had defined. But at the plant level, you can electrify today, get enough renewable electricity through PPA, and then there you go. Even today, you can get CO2 emission reduction benefit. Cost is a problem, is a barrier, I would say. Energy cost is something you need to have a closer look at. In some cases, capital cost could be an issue, but energy cost, in our opinion, is a more important issue when we talk about financing this. Electrification has a lot of co-benefits, but which a lot of people don't talk about. They haven't looked into, including ourselves. We haven't got actually support to look into this, but air pollution reduction, significant production cost reduction, better production control, health benefit, etc. If you quantify those, then electrification can be more appealing, and even if you can put a cost on those things, it will be more cost competitive. And we have upcoming carbon market in China. There's a carbon market, but it's only for power sector. Very soon, they're going to include industries. And also, as we said, renewable power generation is increasing significantly in China. So these are all good for electrification and will help. Yeah, I don't really have time to get into this, but recommendation, basically, we say don't wait until grid is clean or renewable is cheap. You can start now. Identify sweet spots. Sweet spots are where you can have cleaner grid. In China, there are all these different provinces, certain places you can generate renewable electricity at a cheaper price, and there you go. Or the local regulatory framework or policy is more favorable. So identify those places, identify industries that are easier to electrify, especially lighter industry. We are talking about textile, food, and other sectors. These are, I would say, easier to electrify. And honestly, electrification is the main way to get these industries to net zero. You can't put CCS on those sectors. So identify sweet spots and do it today. But make sure from beginning there is a concrete plan that renewable electricity will be added gradually to get these to the threshold that you get the CO2 benefit soon, hopefully by 2030. Then there are different actions that government and industry should take. Chinese government need to put in place a concrete plan, roadmap, policy support for electrification. China has done a great job in the past 15 years with the top 1,000 and now top 10,000 plan industry. One of the most successful industrial policy in the world in terms of impact. So they need to think more beyond energy efficiency and conventional measures, and then think about electrification and other more emerging technologies and look at other pillars. And providing the support through that framework, I think, can go a long way, plus the financing that is needed. A number of other measures we have listed here. Certainly, you need to develop the workforce because we are talking about some new technologies that people need to start getting familiar to operate. So with that, I would like to conclude. Thank you, and open it for Q&A. The report is published, available on our website. You can download and read much more detail in the report. Okay, let me stop sharing. If you have questions, please type it in the chat box. That's how we are going to run the Q&A. Cecilia will moderate the Q&A. So, yes, Cecilia, maybe you can go ahead and start reading some of the questions and comments.
Yeah, so yeah, as Ali mentioned, please go ahead and directly type into the chat box. We'll start with a question from Jeffrey Risman. And Jeffrey asks about PPAs in China, power purchase agreements in China for industrial customers. So can industrial firms use a PPA to secure new renewable electricity supply, or are they usually for power delivered off-grid, for example, for dedicated projects directly connected to the industrial facility? Or is it more typical for an industrial facility to pay the utility to procure a certain amount of renewable electricity for the grid and then do credits for the clean power that's being added, which I think is a model that we may see in some other countries. So yeah, getting into the nitty-gritty of how renewable electricity supply could be procured for some of these industrial facilities.
Nan or Hongyu, I think you know more
So
about.
I will call on my colleague Bo Shen and to help kind of and answer that question. Bo has looked into some of this issue before. No, actually working on some of the power sector side and of financing mechanism like that. So, Bo? Are you able to?
Yeah, perfect. Bo, can you unmute yourself? Or Cecilia, maybe you can help to unmute.
You should be able to if he's there.
Maybe it's away.
Okay. Yeah, so I think
Or I
that's
can- Go ahead.
so I think some of the issue we actually looked into in the past, actually when we had a boiler project and bundling those. I think some of these mechanisms Jeff mentioned and could be viable, but it really is to get to the scale. So I would think like a similar and approach by bundling those small projects. So there could be this larger scale. So there could be these aggregators and companies and using this PPA and to actually get the financing and then to provide those renewable electricity to private sector. It wasn't renewable. It was about energy efficiency in the past, but that approach was tried before. So I think this definitely could be and some model for the electrification using renewable.
And we
Next
also
question.
we also have a question from Yuga Ma about if there are any successful examples of innovative financing to share or reduce the burden of increased OpEx for industries. So especially for the technologies we studied, especially energy costs. Yeah, passing that question on.
I talked to industrial heat pump providers in the US, and they have one. This is one example. So what they do heat as a service. They go find their customers and they say, okay, we are going to provide this heat to you that you need, for example, steam you need at this cost. Of course, they will run the analysis to make sure it makes sense, and they say, okay, we are going to do this using our heat pump, etc. So there is that. So heat as a service, I think that's something people should look into more in different countries. So that firsthand I learned from people who are doing it in the US and perhaps internationally. And then there are corporates now. I know they are looking to, again, we are doing some work with textile apparel industry and their supply chain decarbonization in Asia. And they are aware that it's mostly operational cost issue, actually less of a capex. So they are trying to come up with some scheme to support the OpEx thing. But to my knowledge, at least talking to some of these big brands, they haven't come up or finalized their approach yet. But there are some approaches out there, and these two are the example I mentioned.
If I may add,
Yes.
yeah, I agree with Ali, and I think that heat as a service is it's not necessarily new financing model, but it's a new business model, and that could be combined with innovative financing because and they guarantee the energy intensity and then carbon intensity as well, and then that's how they can probably get the a loan from the banks with more of those credibility. And so, yeah, so I think that with that one, they can actually use and a combination of the solutions, right? Not just on single technology, what typically is done, but with that, and then they could have a package solution.
I'm going to group the next two questions from Alvin and Kristen because they're about some of the, Kirsten, because they're about some of the specific subsectors that we studied. And so Alvin asked a little bit of clarification on our method. So for looking at electrification of the secondary aluminum industry, this didn't include, for example, using cleaner electricity for primary aluminum production. And to clarify that's correct. And similarly, the CO2 reduction potential and additional demand for the steel analysis, that was referring to switching from the blast furnace, basic oxygen furnace route to the electric arc furnace route. So I think Ali can elaborate a little bit on the different kinds of steel electrification technologies that we looked at. And Kirsten also mentions the chemicals and industry, where there could be additional benefits, for example, better selectivity and yield because of better temperature control.
Yeah, thank you. So yeah, to Alvin's question, yeah, for aluminum, we looked at secondary aluminum because primary aluminum is already electrified electrolysis. Before, of course, you have the alumina production, and that uses a lot of fuel, and actually there's potential for electrification there. We didn't look into that. What we looked was the secondary aluminum production and just that melting process, and so that's the result for that. For the steel industry, we have two chapters in the report. One is actually for the steel production, we looked at blast furnace PF buff route and compare it to electric arc furnace, green hydrogen DRI, and the other one electrolysis of iron ore. And these are three alternative electrified steel production, or mostly electrified steel production. Hydrogen DRI is like an indirect electrification through, electricity goes green hydrogen and then hydrogen DRI. So there's that chapter, those alternatives are compared. And then there is another chapter where we looked at steel reheating. When you produce a steel, when you go to the final stage, there is a rolling finishing process. There is a process there called reheating furnace. I think it's the most energy consuming process after the steel production, crude steel production. So you can actually electrify that. Currently it's fossil fuel based. You can electrify that steel reheating. And that is a separate chapter we have analyzed. So these are the two types of analysis we have done for steel industry. And correct on the chemical industry and any other actually electrification, it does add significant other benefits to the process.
We also have a question about the cement sector, which does use very high temperature, over 1,000 degrees. And so generally asks about potential of electrification in the cement sector.
We are actually doing analysis for electrification of cement industry. We didn't manage to include in this report. We are going to have it in our next report. Every report we do, we try to add a few new sectors. If you look at our first report for US was 12 sector. Now we have 14 sector. Next report, hopefully we will have 15 to 20 different sectors. Cement is one we include. Yes, it's harder to electrify. To electrify the kiln itself is more challenging, but around 60% of energy use and 70% of emission in cement production is actually from the pre-calciner. So that's where 60% of energy use and 70% of emission. So you can actually electrify that relatively easier because it's not a rotating kind of equipment. And there are already technologies being developed, the ley-like technology that does the indirect heating for that pre-calciner. And that indirect heating technology currently is natural gas-based or fossil fuel-based, but it easily can be electric-based. And they're already working on it to make that electric-based indirect heating. If that happens, you can basically electrify 60% plus of the energy used in a cement plant. Another significant additional benefit is once you do indirect pre-calciner heating, then you don't mix combustion gases to the process-related emission, which is more than half of the emissions in the cement industry. So you don't have combustion emission because electric, but even if you have combustion emission, if it's indirect heating, it doesn't get mixed with the process-related emission from calcination chemical reaction. So you will have near pure CO2 from this calcination that is emitted, and it's more than half of the emissions from cement plant. And when you have near pure CO2, it's very easy and very cheap to capture. So it becomes a significant co-benefit if you can electrify the pre-calciner and tie it with CCS. People are working on it. I know we are at the time, but we can go ahead with another, because our presentation was long, maybe another couple of minutes, couple of questions, and whoever can stay longer, we can continue a little bit more. Cecilia?
For now, we just have one more question from Kaidi Guo. Kaidi points out that the energy costs itself in our electrified scenario would exceed that of the conventional technologies, which indicates that without considering capital costs, the electrified scenario is more expensive, and asked to elaborate about the assumptions in the model.
I would say, please look at our report. We have, I believe, listed our assumptions there on the cost and other details. So, yeah, it's details on our report. Okay, looks like that's the last question, but thank you so much everyone for attending. I hope you find it helpful. Please look at our website. Also, we launched a new website for Industrial Electrification Center. That will be the platform where we will share more information about our work on this industrial electrification globally. We are doing a number of projects now on this topic around the world, so we will share that more with you. Nan, do you have any closing remarks?
No, yeah, thank you all for participating in this webinar, and your suggestions and questions will be very valuable to us for our future follow-on work. Yeah, with that, I want to thank our founder and Climate Imperative and the manager and Mengfei, and I thought she was on the line, and for her support. And then thanks to our GEI colleagues for the really wonderful collaboration.
Great. Thank you, Nan. Thanks, everyone, and have a nice day or nice evening. Bye.
Thank you.